Welcome, welcome to Current Science. Today, we are going to talk about an amazing math topic on numbers. Not the numbers we use in our everyday lives. We are going to do a bit of imagination today. Guess the numbers we are going to talk about. Yes, you were right. Imaginary numbers. Let's look at what these numbers are and what we accomplish in this video. Look at what imaginary numbers are, the basic operations on imaginary numbers, and the powers of I. We'll discover what I is later in this video. Without wasting my time, let's get going. Well, before we get to our main discussion, I'd like us to try some few questions. The root of 25. You'll be like, oh, this is too easy, my brother. That's 5. What about the cube root of 8? Which number will multiply itself 3 times to give us 8? That number is 2. The answer is 2. What about the cube root of negative 125? Realize that negative 5 times negative 5 times negative 5 will give us negative 125. So the cube root of negative 125 is negative 5. Now, we're able to find the cube root of negative 125. What about the root of a negative number? Say the root of negative 25. What two numbers will multiply to give us negative 25? Maybe you might be thinking negative 5. But let's see. Negative 5 times negative 5 unfortunately gives us positive 25. So our problem is still there. What about negative 5 multiplying 5? Yes, it will give us negative 25. But there's a problem. They are not the same. For us to get the square root, they should be the same. So we don't have an answer here. But that's where imaginary numbers come to play. Okay. What about the root of negative 16? Think of any two numbers that will give you negative 16. Should I give you time? I'm not sure you finished today. One thing we should note is that I is equal to the root of negative 1. So I is what all this is about. Imaginary numbers are based on the concept of I, the root of negative 1. So now we can go back to our questions we had earlier. We having challenges with them. Because if you point them in a calculator in the normal math mode, it will even give you math error. If you go to the complex mode, it will give you something. And that something is what we are come to do. So when we have the root of negative 25, we can express it as the root of 25 multiplying negative 1. And that will be the same as the root of 25 multiplying the root of what? Negative 1. We get the root of 5 is what? 5. And say root of negative 1 is I. So 5I. What about the root of negative 16? I'd like you to do that one. And the final answer you get is 4I. I hope you get it. Very good. Now, let's talk about what they are. So an imaginary number, any real number multiplied by the square root of negative 1. When we multiply a real number by the square root of negative 1, and we discover that the square root of negative 1 is I, you get an imaginary number. So for example, 2I, 3I, 4I, 5I, 6I, root of 7I, all those things attached to I give us imaginary numbers. Very nice, right? Then now let's look at the powers of I. Say I to the exponent 0. From indices, any number, a to the exponent 0 is equal to 1. Except a is equal to 0. So a is representing any real number. The same thing for I. When you have I to the exponent 0, you get 1 to be your answer. Also, I to the exponent 1. From indices a to the exponent 1 is equal to a. So I to the exponent 1 is equal to what? I. Now I to the exponent 2 is equal to the root of negative 1 squared. Since we know I is equal to the root of negative 1, we can just put it in. This will take off this, so we get negative 1. So I squared is equal to negative 1. What about I cube? So we know I cube can be written as I squared multiplying I to the exponent 1. From indices, when you have something like this, and the bases are the same, you just add the powers. 2 plus 1, and get 3. So it will be I squared, which is negative 1, multiplying I, which is I to the exponent 1. So I cube is equal to negative I. What about I to the exponent 4? That will be equal to I squared all squared. And that will be negative 1 squared. So you get an answer to be what? 1. Simple as that. So let's summarize all these in a table. So when we have I to the exponent 0, we get 1. I to the exponent 1 is I. I to the exponent 2 is negative 1. Negative I to the exponent 4 is 1. Now when you continue and continue and continue and continue, you realize a certain pattern. You see, when you go from 1 to 4, the pattern is I negative 1, negative I 1. When you come from 5 to 8, it's the same pattern. Meaning for every 4 powers, the pattern is positive I, positive 1, negative I, and positive 1. In a way to remember this, remember that the positive ones are the ends. So I and positive 1 are the ends, and the negative ones are in the middle. And none of them is close to its negative counterpart. So that's a way to remember. So let's say you have I to the exponent 7. I to the exponent 7. Know that I to the exponent 7 is close to a multiple of 4. And that multiple of 4 is 8. So it means that multiple of 4 will be what? I to that multiple of 4 will be 1. Now this one is 1 less than the multiple of 4, meaning it will correspond to the value of I to the exponent 3. And that will give us negative I. Simple. I to the exponent 9 will correspond to the value of I to the exponent 1. This is where 3 less than 12, which is a multiple of 4. So you get 1. Alright, so it's equal to I. So that's the way to do it so quickly. Now you've seen the shortcut. Why don't you try these questions and send your answer in the comment field? I to the exponent 43, I to the exponent 12, I to the exponent 21, I to the exponent 10, I to the exponent 15. I'll be expecting your answers in the comment field. If you have any challenge, we can also address it in our subsequent videos by stating them in the comment field. Okay, now let's look at some basic operations on imaginary numbers. We'll first look at addition. We have an example here. We have the root of negative 9 adding to the root of negative 49. All you do is, the root of negative 9 is the same as root of 9 multiplying the root of negative 1. So that will be 3i. Then now we add it to root of negative 49 in the same way, 7i. So all you do is you add the numbers in front of I and you get 10. And you attach the I. Simple. That's the same for subtraction too. You do the same thing and subtract the numbers in front of I and attach I. Isn't it so simple? Imagination is good. Now we should know something for the multiplication. We have the root of negative a multiplying the root of negative b. The answer you get is not the root of negative a times negative b. You see, under normal circumstances, we know that root of a times root of b is equal to this. But here we are saying that for imaginary numbers that's not the case. So rather you bring out I and you get root of ai multiplying root of bi. And now we know that I times I is I squared. And here now we have the normal thing, so ab. So root of ab. So I squared root ab. And you know I squared is equal to -1. So the answer will be negative root ab. Simple. So try the root of -7 multiplying the root of -5. That will be negative the root of 7 times 5. And that will be negative root 35. Very good. Now let's look at division 2. When you have the root of negative a on the root of negative b, can bring I out and I cancels out. So you get the root of a on b. Simple. So we have the root of negative 30 being divided by the root of negative 15 to be the root of 30 on 15. And that's root of 2. Simple. So try these questions and send your answer to the comment field so that next time we can have a fruitful discussion like this one. The root of negative 81 plus the root of negative 256. Also, the root of negative 576 on the root of negative 144. Now, the root of negative 7 multiplying the root of negative 15. Try these questions. You can pause the video to copy them down. Send your answers via the comment field. Thank you for watching. See you another time. Bye.